All right. So how's everyone doing?
Good.
Awesome.
Real good.
Okay, yeah, I know I asked this like 3 times in the past couple of minutes. But today we're going to talk about Bash and Git. Before we get into material, I just wanted to remind you guys that we have a questions doc, and I saw that Kishore, you added a question there and I put an answer to it. So just to remind you where that is, let's see, this is my desktop on Slack. If we look at our class channel up here, there's this link to a spreadsheet with a bunch of things. And here, there's a questions document. And feel free to leave your questions here. So Kishore had a question here about like when to use parentheses, square brackets, braces. There's a lot of that all over the place. So I gave a little quick answer of like what each of them is for. So just know that this question sheet is here. I know it takes some time to get used to like using it, but at the end of the program, you're going to be glad that like you have all your questions in one place, sorted by sections. So just wanted to remind you guys that that is there. Before we start talking about material, does anyone have any questions about things, anything from section 1 or anything from section 2? Just before we get started.
I think maybe it was in section 2, 1 or 2. I can't remember where it gave the link to the desktop, the GitHub desktop.
Ooh, okay, yeah.
So the one before that, I didn't understand. My teacher, who's James, said that we should clone it twice and somehow put one of them into a documents file.
Okay.
And is that like maybe
right.
including notes or something? Like that I kind of lost that.
All right, I think he probably means that you want to always clone a version of your lab and just to like keep on your local machine. And you can use this thing called GitHub Desktop, which I won't really talk about because I personally only found out about it from James himself last.
Okay.
It allows you to use all of GitHub's functionality like on its own like little software. So that's what GitHub Desktop is. I won't talk too much about it, but like feel free to like check it out if you want.
Okay.
But yeah, GitHub Desktop is pretty cool. He was showing me like a lot of its functions. You can like see changes that you've made in like a window.
Right.
That stuff is really cool. I unfortunately only found out about it last week.
Okay. Well then maybe another time.
Yeah. All right. Any other questions or like things that you want me to specifically address?
I have a question about cloning. Like what, I guess I'm just confused as to like why we clone. Like, am I supposed to be working within this clone instead of the actual Learn website and like be saving everything that I'm doing? Because like I'm just going through Learn, and I mean I think I've figured out how to fork and clone and all that stuff now. But I'm confused as to if we're supposed to be using that clone and just saving our work that way.
So short answer, we should be always cloning our work and working off a Jupyter notebook.
Okay.
What cloning is, I'll actually get to that as we like talk about these processes of like using Git. So hopefully that'll clear things up. I know you had an issue, Zach, you had an issue with like cloning on your computer.
Yeah, I think I figured it out.
Cool.
So I think I'm good on that.
All right, but that specifically, if you needed help, because I think that's a very special problem. You can fix that during a one-on-one if it still doesn't work.
Okay.
Anything else? I will get to that later.
I have a question.
Priscilla?
So for the Shakespeare or the Macbeth project, right? Should we have known like everything? I know it said like Google stuff, but it felt, at least for me, like there was just some stuff that I did not know I needed to Google, and I was like, oh, that I wouldn't have thought of that. Because like I in my mind I thought I had the process as to like it's this, that, and that, but it just didn't connect with me, so I'm just not sure if that's supposed to happen or if it's just
Yeah.
me.
The point of that Macbeth project was to freak you out.
Oh, okay.
So
Good.
no worries. Yeah, because like I know like I've been talking with quite a few of you about like they have like lambdas for sorting. They have like this crazy for loop. They have a list comprehension as well, which are all things that are actually taught more in depth, or actually they are taught in later sections. So it's really awesome that you started Googling stuff, because that's really like the best skill you can take away from this. But yeah, the Macbeth project is really, it's supposed to be like ridiculously hard for section 1. So glad you all struggled. That's gonna keep happening. No worries. But yeah.
Can you explain more what Lambda is? Like when I was trying to figure it out, like most of the concepts made sense, but I had never seen that, and I don't know, I couldn't wrap my head around what that was doing.
Yeah. So lambdas, I will actually talk more about lambdas in the next section, section 3. So I use lambdas in 3 specific scenarios. I personally there are several different schools of programming, and Python is functional programming, where we write functions and we get things done through functions, basically. That's functional programming. But there's this other school of programming known as dynamic programming, where they don't write functions. I don't know that whole side of programming, and lambdas are used in that a lot. So as you've seen in like lambdas help you basically with a lambda, you are like getting something done without having to define a function. It's like if you want to get something done like one-off, you would write a lambda for it. But I'd say in Python, we don't, and especially for data science, because for data science, we're replicating a lot of things. We don't use it that much, except for in 3 specific scenarios, one of which I will talk about. So one of them is for sorting. I actually use it for sorting quite a bit. If you're sorting like, I think in that specific one, it was a list of 2. And that specific example, I'll actually talk about on Thursday. I use it to do filters or maps. So like, I think in like the pre-bootcamp prep track, we had a little bit of like list. It was like list map lambdas, and that's one instance that I use lambdas a lot. And very similar to that is list filter lambda, which I will also talk about on Thursday. And then finally, in pandas, which we'll talk about in section 5. Those are really the 3 instances that I've used lambdas. And outside of that, I have no idea how lambdas work.
Okay, cool.
Yeah, so yeah, lambdas are a hard concept to grasp. I think, yeah, it's great that it exists. But I think sometimes it's just easier to write functions. It's a lot clearer. But yeah, we'll get to lambdas eventually. And if we have time after this, I can maybe talk about that specific Macbeth example. Cool. Okay. So let's get started with Bash and Git. The way that the labs are laid out sort of goes through everything that you need to know, but I'm going to take a slightly different approach and demonstrate how we use Git, especially Git, in 2 specific scenarios. And so first I'm going to just talk about like what it means when we're doing like the fork and clone. I think that is very important to understand. And then I'm going to talk about the idea of an upstream by having us all together clone our our study group repository. So I don't know if you've noticed, but on that spreadsheet that I had linked in the Slack, there's actually a link to a study group materials. And let me just share what that is really quick. So that looks like this, where from now on, whenever I have like a notebook that I'm using during a study group, I'm gonna upload it onto here, either probably like before each study group, so that there's like a blank copy that we can all like, if you all wanna follow along during the study group, we can do that. So in the future, and I'm gonna teach you guys how to set this up, we're gonna all have this. I'm gonna upload material onto here, and you're gonna be able to pull down the material right before a study group. So that's the second thing that we're gonna do. And hopefully like through these 2 contexts, we're gonna explain all the things that we need to know about Bash and Git. Sound good? Any questions before we get started? Cool. All right.
Clone this?
Sorry, what was that?
You need to clone this, or
We'll talk about that later. Don't clone it now. Don't clone it now because we're gonna. But we will. I'll go through the steps of what to do. Yeah. So let's start talking about cloning, and I'll just go to a random lab, and I'll show us what we're supposed to be doing when we're cloning a lab. So I'm gonna pick a random one, maybe like a later one here, using nested loops lab. So what you should be doing when you're working on any lab, I'm just gonna go through the process so we know, is that especially if it's a lab that you have to code your own, like you have to write your own code, like usually in our curriculum, we have like a reading and a lab. Readings, you can choose to clone or not because you have lifelong access to all this material. It'll be on the internet, but some people like to clone it down. But if you ever want to like save your work and like have access to like the code that you write, you're gonna have to go through this cloning process. So if any of you have been working off of learn.co and like you're writing code here and you find that, you're gonna find that doesn't save. That sucks. Basically, I don't think we can handle everyone's saved work on learn.co. But anyways, how we do that is we just click onto this GitHub button. We make sure to fork it. So forking it is very important. How we know we're on a right version is that this version is owned by LearnCo students. And so we can't make edits to LearnCo students because LearnCo students is the version of the lab that's on learn.co. And we don't want our answers to be visible to everyone. Neither are we even allowed to change this. We don't have edit access on this version. And so what forking means, forking creates a copy of this to your own GitHub. So you'll see when I click fork, and I have a lot of different options, that you should have your own username here. But when I click fork, it's gonna take a while to fork and like basically copy everything over. This you can see is owned by me. So this has my username attached. A lot of places that you can check for this. In the URL up here, it's my name as well. And that's how I know this version is my version. So whatever changes I make to this won't affect LearnCo students. That's the main reason why we want to fork the lab. So we can make a copy of the blank lab, fork it over such that we can work on our own stuff and like just play with whatever is on the lab. So that's what forking does. And now cloning is just what allows us to work on it locally. And so there are two places that code exists, locally and remotely. So whatever's on GitHub, whatever's on the internet is remote, and whatever is on your computer that you've like Git cloned is local. So you want to work on your labs locally using Jupyter Notebook. So how we do that, and there are many little things to watch out for. To clone the lab, one, you want to make sure that it's your version. But here, there are different ways that you can clone. There is HTTPS. You want to make sure that it is HTTPS. There's this other one, SSH, where you need more credentials. So don't do that. Make sure that it's HTTPS. You just want to copy this. This is the link that you want to copy. And again, just double check that it's your username. So you're copying that, and that's what you get cloned. Minor segue, little segue. In the labs, it talks about this thing called branches. And for those of you who don't know yet, this is where you can access the solutions to the lab. So if you go into master here on the top right, top left, you'll find that there's a solutions branch. We'll talk about branching a little bit later, and we'll go more in depth into like what it's used for, what it means. But here's where you can find like all the solutions to the labs. One thing I want to reiterate is that solutions were written by curriculum writers, and there are many, many ways you can solve one problem. So solutions are not always the best. I mean, it's not the only way and not always the best way. As you start coding more and more, you're going to develop your own style of programming. So if something doesn't make sense in the solutions and you think you can do it in a different way, by all means, just as long as the output's the same. But cool, just wanted to like let y'all know that that is there. Cool. So let me change this share so I can just demonstrate how Git Clone works. So here I have my terminal. Let me close this. I have my terminal. I'm going to make this, oops, let's make this a little bigger. I think I can close. Yeah, let's close this up. And make this a little bigger. All right. So CD brings us back and Command K clears everything. So to git clone, first I want to find out where I want to clone it, right? And I actually have a folder called labs somewhere, so I'm going to navigate into it. So I made a folder called DS, and I think it's in labs. Cool. And what I'm going to do is I'm going to go git clone, and that's how I clone the lab. So ideally, what happens is I open up a lab, and okay, I didn't CD in, so this one was here, using nested loops. So what's gonna happen as you work on labs is, let's say I'm working on some stuff here. All right, code goes here, and just as an example, I'm gonna write, let's see, I'm just gonna write another comment. This was my code. And I'm gonna save that and close it out, because I wanna demonstrate how to push your changes back up. So I've saved this. I'm going to close it out. We're going to go back to our terminal. So I finished working on this lab. I quit this notebook. So Control C to quit the notebook. And here's when we start using a little bit of Git. So really quickly, something that you should always do before you do anything is Git Status. Git Status just tells you the status of your repository. Okay, just kidding. I have to CD into the repository first. Let's see, using nested loops lab. All right, there we go. So we're gonna do Git Status. So it's good to get used to reading this stuff. I know sometimes it can be a little scary because it looks like you're messing with the matrix, but here you can see that you have changes not staged for commit. So you see that this index.ipynb was modified, which is right. I added a little comment to that, to one cell. And so to do that, there are three main steps that you have to do. Oh, another thing to look out for, sorry, I'm going all over the place, is to check that your branch is up to date. Because sometimes changes can be made in the remote that you don't have locally. But actually, wait, don't worry about that now. Talk about that later. But what we're gonna do, let's do git add, and you can do git add, and I like to do git add space period because that just means it's adding everything. Nothing's gonna output, that's normal. You do git commit -m, and you have to put a message, worked on the lab. Commit message is important to write something that makes sense. I've been called out for having trash commit messages. So do that. And then you can see that something's changed. And then you do git push. I'll explain what all of these steps are doing in more detail, but I just wanted to show you that when you do a git push, it's gonna write some stuff and it's gonna push your stuff to the remote. So what's really cool is that when I go back to my fork copy on GitHub here, and let's say refresh this, you see my commit here. And that's ideally what we want to see. You can see this is the message that I had added earlier. And just to double check, if I go into index.ipynb, hopefully it loads up. You should be able to see the little change that I've made. So I'd say it's always a good practice to push your changes up onto GitHub so that if we ever wanted to like look at your work, we can do that through here. So if you had like a question about something that you were doing, just send us the link to this and we can see what code you're writing and we can help you out. Sometimes this takes a while to render. So I'm pretty sure that it worked based on the fact that there's the commit message here. But this is basically updating the changes in the remote from your local. Sound good? So
one quick question is, so now when you do git add and like you do the space and the space and the period is not compulsory?
You need to git add something. So usually normally, if you only change one file, you can do git add file, the file name.
Okay.
I just like to make sure I'm adding everything. Like maybe I accidentally like edited another file. I would do git add space period. So it's just everything.
Yeah, that's what I thought. Like if you just add the period, it's like anything that you have made the changes as, right? It would do it.
Yep.
But then you can specifically also add things. That's what I'm understanding now.
Yep. Yeah, exactly. So Git, that's what makes Git really powerful, is that it's a version control thing. So it can automatically, when you do the space period, it basically scans your files to see like what changes you've made locally that don't currently exist in the remote. Cool. Yeah. So
Would you be able to tell how to add files later on whenever?
it's the same syntax. It's just git add. So instead of doing git add space period, you just git add the file name. So git add index.ipynb. Usually I pretty much 99.5% of the time just use git add space period.
Okay.
Mm-hmm.
That makes it easier and right, good.
So I want to.
So I have a question.
Oh yeah.
When you're doing, like if you have files that go, I have a Flatiron file, and then underneath it I have section 1, section 2, section 3. So I can upload them, and I can push them by section. Is that how that works then?
Unfortunately not.
Okay.
So you have to do it by repository. So you have to do it by labs. Yeah.
All right.
Kind of for safety as well, I think. But yeah.
Okay, thanks.
All right. I think Jeremy, do you want to ask a question?
Yeah, sorry, I didn't realize I had myself muted. So the process with this is on Learn, we fork it and clone it in, and then we open Jupyter Books, we do whatever the assignment is, and then we do what we just talked about after that to load it up into our depository. Am I looking at that right?
Yeah, exactly.
Okay, okay.
All right, so I'm gonna draw like a diagram that hopefully might help some of you understand it better. So here, I'm gonna, writing. All right, here I have remote, and here I have local. So I'm gonna just outline again the process of what you're doing when you're cloning a lab. So here we have remote, here we have local. So this remote, I should have done a different color, but I'm gonna call this the Learn co-remote. So this is the version of the version that's on curriculum, the version that you cannot edit. So the first thing that we did was we made a fork. I'm gonna use a different color. So what we did here is we forked it, and then we have a new remote that is your personal remote. Cool. So that is done on GitHub. So now everything only exists on the remote space. You want to get your remote local, and that process is, let's see, this arrow, that process is Git Clone. Things to make sure is that you use the HTTPS URL. So let's say you're working, and then you make some changes. So this is an updated file. I'll call this the updated file. And I want to update this version. I want to update the remote. I want to update your personal remote. So the 3 steps that we had were add, commit, and push. So it may seem kind of redundant. Why do we have to do these 3 steps to like just get it up there? I think it's mainly to just make sure that you're not doing anything you're not supposed to do. So the first thing you do is git add. And git add, you might have seen this word used around, but git add space period. It's staging your commits. So you're only like telling him what changes are to be made, but you haven't like committed to them yet. And so this process of git add allows you to make comparisons to what already exists and what new changes you've just made. So that's called like staging your changes. The proper word is staging. So I'm gonna write that here, staging. The next step is doing the commit. So then you have git commit -m, and then in quotes, you have to add your message. So this step actually stores your commits in the cloud, or not the cloud, but in like remote space. Because GitHub itself is one of many places that you can host repositories on. So there are other websites like GitHub that are not as widely used. So the commits basically say, okay, these changes are definitely happening. And then finally, after doing the git commit, then you have the git push. And that is basically like, all right, I know that that's where my stuff's gonna go. And how that knows, well, does anyone have any questions about this diagram before? All right, I'm gonna screenshot this just so I can like, does anyone know how to screenshot on an Apple device? Just really quickly. Let's see. Oh, save to photos, awesome. Okay, great. I'm not an Apple user. Okay, so before I move on to like the second way of using Git for our purposes, I want to share my whole screen again. Actually, no, I just need.
Can I add something?
Yeah, what's up?
Yeah. So I mean, what I do is like from the terminal itself, I directly, once I've opened the book, I mean, when I go to that folder, I directly go from there right to the Jupyter notebook.
Yeah.
So, I mean, I find that easier because while I'm coming back to actually clone it, the folder already exists.
Okay.
So while I don't have to CD again.
Oh, okay. Yeah. Yeah, it doesn't really matter at which point you open the Jupyter notebook, as long as you open the Jupyter notebook before that point. So for example, like earlier we saw that, sorry, I keep changing this share, but earlier we saw that I opened my Jupyter notebook not in, let's see. Earlier I opened it here. I opened it in my labs folder. So when I opened it in my labs folder, what opened was all of my labs. So I could just like, you can clone everything and then just work in your labs individually and then just push them up individually. Rather than if I were to open it up from like, if I were to CD into using nested loops, and if I open Jupyter Notebook here, I get directly into those files.
Yeah, so this is where when I save it and go back, right, it actually remains at the same folder.
Yeah. So that's like it's like a workflow. It's a little workflow trick.
Okay.
Cool. So what I wanted to show, since I'm sharing the screen, I'll just do this here, is how does Git know where to push your stuff to? Something that I did mention to a couple people is if you can find the remote URL. So not super important to know, but something that's good to know is you can do git remote --v to see what the remote URLs are. Let me just make this so it's better. So here you can see that I did git remote -v, and it gives me the 2 URLs of my forked repository. So basically it knows that, okay, when I'm pushing changes, I'm gonna push it to this URL. It also knows that if I'm fetching new changes, I'll fetch it from this URL as well. So that's just something that's good to be aware of, that that's how Git's working. Cool? All right, so now for this next part, I'm gonna show you guys how we're gonna use Git for our study group notes. Maybe follow along if you want, but I actually do have all the steps listed here. But I'm just going to go through and explain what they are. So up to you whether you want to follow along and do this right now. So let's just follow the steps and see. How this is going to work, actually, let me think. Yeah, how this is going to work is that this repository, as I mentioned earlier, is something that I'm going to update every time we have a study group that I'm gonna want to like use a notebook and like so that you can have these notes. So maybe like twice a week, I'll be updating this stuff and you'll be pulling changes. So the one difference is that, as you remember, if you see from here, you're not going to be fetching changes from your forked copy because your forked copy won't have my changes. Cool. So we'll have to like edit it such that it fetches new changes from my version, and then so you can get all of my new files every time we have a new study group, and work on that. This will hopefully make a little more sense as we're going through it. So the link to this stuff is on the Slack channel, so feel free to pull that up whenever. And I'm actually not going to save this here. I'm just going to save this in. Let's do it. I'm just going to make a new file to like test. All right, so I'm going to clone it in here. So what you're going to want to do, I can't do this step because this is my repository, is you're going to want to fork this repository. Let me think if there's a way I can do this.
Is this in Slack now?
It is in Slack. So if you go onto your Slack channel and click this spreadsheet on top, and then it is this one, the study group materials.
Okay.
That's.
Thank you.
I'm actually going to do this with a different example so that I can actually demonstrate the fork process. So I'm going to do a completely different repository. Let's see if I can find it. Yeah, I'm just going to use an old cohorts repository. So what I'm going to do is I'm going to fork. So pretend that this is ours. So I'm going to fork this and clone it. Same as we do with the labs. So here, go into terminal, and I'm going to git clone. Let me just, let me clear this so it's clear as to what's going on. So I'm going to do git clone this lecture repository. It's going to take a while for this because this is a cohort that already graduated and there's a lot of stuff. So, all right. This is cloning. And if we go back to here, fork and clone this repository, that's what I just did. Next, we want to add this version as the upstream. So upstream is something that I'm going to talk about after I do this step. So for this repo is different because I want the upstream to be this Git. So I'm going to do git remote add upstream. And give me a sec, I'll tie it all together. I always forget to cd into the, all right, so here, git remote add upstream. Cool. So remember when I did git remote -v earlier, it had like 2 URLs that told it where to push changes to and where to fetch changes from. What I did was I added this upstream URL that is not mine. So this is owned by LearnCo students, not by me. And so now if I do git remote -v, you can see that here, okay, the origin is this, but the upstream is this. The upstream is the LearnCo students. So imagine that the LearnCo students is my version and this is your version. Whenever I make any changes, you'll be able to pull changes from here and then work on it and then push your finish, like, let's say I have some sample functions in the notebook and you run them while we're doing study group and you want to save those functions, you'll be able to push them to your own personal remote copy. Does that make sense? I'm going to draw a diagram later again, so it makes a little bit more sense. So yeah, if we go back to this, I have pretty much the same steps. When you make changes to the notebook, same things. You're gonna do git add, commit, and push. And so that will just send all your updates, not to my version, but to your version. And here's where the difference is. Usually, if you have just your own version, you'll be just doing a git fetch, not from git fetch upstream. Here, you're making sure to fetch your changes from upstream, which is my version. This is super confusing, I know. But you're gonna fetch to the changes, merge the changes, and then you can push your changes. We'll go through this really, really quick when we start off section 3 on Thursday, because we're gonna have to do this process. So I just wanna draw another diagram of what's going on here, because I think that makes it a little easier to see what's going on. So what we have here is, let's start with, here's remote. And this is version. So this is my stuff that first you fork over here. And this is where you fork it over. You then clone it over and work on it locally. Different color, local, your version. And that's where we're at now. In the future, I'll add notebooks and I'll like create materials that I will push up here. How that's done is not relevant, but I'll do this step and you'll have to pull down these new changes. So we'll call this new stuff. And we're gonna have to do this, right? You wanna get my new changes and get them onto your local version. And this is what git fetch does. It's what git fetch does, and it's also what git merge upstream master does. Upstream master does. So that step at the start where you did the git remote add upstream basically declared this to be upstream. So that's why it knows when you do git merge upstream master to get changes from my version. And so when you do your git fetch, git merge, here you can then like work on some more stuff. You can, here. You can run the code and like do whatever, write some functions, blah, blah, blah. And then finally, to complete the process, you want to do a final git add commit push again. That makes sense? There are a lot of arrows on the screen right now, but does anyone have any questions? I think honestly, a lot of this comes from just like practice and experience, but hopefully this makes it a little clearer as to what's happening.
One quick question now. Right, every time, right, when we start fetching your version, right, and let's say the versions that we have worked on, it contains a lot of errors, and but then like we kept on working on it, and some fine day we achieved the target that okay, that was the perfect code.
Yeah.
You have your remote versions which we fetched again, right? Both of them merged together. What happens on into the the notebook?
Good question. Good question. So the way that fetch works is it knows that you only want to fetch things that the new thing that I've done. So let's say like we have section 1's notebook up there. You've like added a bunch of stuff to section 1's notebook. And when you do a git fetch, you would think that there are some changes, right? Because my section 1 notebook is the blank version and your section 1 notebook has stuff. So there should be some sort of conflict. The really neat thing about Git fetch here is it knows that it's already pulled these changes. So unless the one scenario is that if I make a change to section 1 notebook after you guys have worked on something, then you'll have a conflict. However, I'm gonna make sure that I don't do that because that's not supposed to be what I'm not supposed to do that. So that's the only way that you'll get a conflict, because Git fetch knows that it's already pulled that change. So it knows not to mess with that particular file.
So it's advisable that like once you have made the change, only then we fetch it and then we start working on it.
Yeah, and I'm going to be very mindful. I sometimes still mess this up, but I'm going to be very, very mindful that like I'm not going to change. All of the notebooks on my version are going to be clean blank notebooks. They're not going to be as in clean and blank as in like I wouldn't have like added like the answers and the code and all that. That I will go through during these study groups. That makes sense?
Yeah.
Yeah. So if this messes up, it will be my fault. Let me just save this diagram really quick. Cool.
So is this something that you add notes from your class?
Yeah.
And so we want to clone it after the class as well as if we've worked on it before. I mean, we want to then fetch it.
Yeah, so you only have to clone it once. And then after you've cloned it for the first time, that first time you clone it, everything will be updated. So the first time you clone it, you won't have to do the fetching steps. But subsequently, as I'm adding new material, then you'll just do the fetch steps. If I share this, it'll make a little more sense, hopefully. So here I've laid out all the steps of what you have to do. The first time you do things, you'll just have to do these steps. When you make changes to your notebook, remember to do this. And then when you want to get updated notes, honestly, you can copy and paste. I don't mind. But if you want to get the updated notes, these 3 steps will work. Cool?
So when do we know changes have been made?
When do you know changes will be made? They won't notify you or anything. You can always just do like a git fetch to check. I will usually just tell you guys to pull notes right before a study group. But yeah, there's nothing that will like notify you if changes have been made. You can always do a git fetch, and the git fetch will actually tell you if there are new things. But yeah, you would just have to remember to do that once in a while.
Okay.
Any other questions? Because there's one last thing that I want to talk about, which is branching and stashing. Two things. Or I guess I can also talk about. There's a lot of things I can talk about that are like kind of important to know, but not super important. Cool. Few of the small things about Git to remember. I guess first I'll talk about what branching is. So the way that LearnCo uses branches is very different from how branches are typically used. So let me close all of this out. So branches for LearnCo are used to like denote what's the master branch, which is the blank notebook, and which one is the solution notebook. So usually how people use branches like in production, has anyone heard the term like don't push to master? I guess like you would have to know what it is. But anyways, there's like this little thing, there's this like little running joke where like if you're making changes to like a file or something, you never want to push to master. You always want to push it to somewhere else to make sure that it works before you push to master. So let's say that this is a project of mine. I'm going to fork it just in case I mess it up. But let's say this is a project of mine and I want to like do some insane analysis on like loops. Usually what you would do, and we'll actually talk about this when we get to doing our mod 1 project, is you want to make a branch to make your changes on first. So what you're doing when you create a branch is you basically it's kind of similar to a fork, but within the same repository, you're making a copy. So actually, I think I might be able to create a new branch. Yeah. Usually you make what's called a work in progress branch. So let's do this. and let's make this work in progress branch. I'll be working on some stuff, and I want to make sure that it works on my work in progress branch before I take these new changes and push them to master, because master is the master copy. I don't want to like mess with that with this new stuff that I'm testing. So that's what branches are usually used for. Does that make sense? So whenever you're creating a new branch, it literally just makes a copy of master, and then you can then like make changes onto there. So let's like really quickly just make some changes here. I know that these changes will be fine. Loops are great. That's my change. Cool. So I'm just gonna edit and make these changes. So see, I'm still on my branch. And what you would do, so let's say I've checked that my changes work, this new like feature that I've added to my project, it works. What you would do is then you do something called a merge. And so how we can do it, I think the easiest way to do it is on GitHub itself, because it's very visual. And we'll go more in depth on this when we get to our projects. But we're gonna make sure that it goes to, so we're gonna compare my work in progress branch to the master branch. And we're just gonna take all my changes that I definitely know work from my work in progress branch and then push it to master. So it's always just making sure that you're not adding any new things that could like potentially break your whole system. It's like giving yourself a test layer. So we'll walk through this again when we get to projects, but
just one quick question: why do when do we use the pull request on the top?
Yeah, that will be more relevant when we get to project, but basically a pull request is a request to merge something into another branch.
Okay.
So basically I clicked all the green buttons, which is why I tell people to always click the green buttons. And then I successfully merged my branches. And then because now my branches changes are on the master's changes, it's redundant and I can delete it. I know that was a lot of information. I'm definitely going to go through this again when we get to the projects, especially this branching part. So that is branching. Any questions about branches? All right, so there's branches. On the Learn Labs, they mentioned this thing called Git init. So they have you like create a repository locally and then turning it into a Git repository. That is one way to do it. I actually prefer just creating my repositories on GitHub and then cloning them down. They essentially do the exact same thing. One cool thing to note is that how you know something is a Git repository is when you do, I think it's ls, which is what lists all the files. I think it's -a. How you know something is a Git repository is it has this .git file. So anything that has a .git file is a Git repository. Usually if you do the normal ls, it doesn't show up because anything that starts with a period is a secret file, is what they call it. But just know that if something is a Git repository, it always has this .git. And when you do a Git init, it just creates that .git file. So that's Git init. Any questions about that? I know the lab actually walks through that process of doing Git init and creating a repository locally. Cool, so that's Git init. The last thing that I wanted to mention was Git Stash. I think there's a whole section on Git Stash on Learn. I also realized that I was typing this whole thing where you couldn't even see my terminal. So let me just do that again real quick. What I was trying to show that when you do ls-a, actually let me clear this so it's cleaner. When I do ls-a, this is what you're looking for, the .git file. And because it starts with a period, if you do a regular ls, it doesn't show up. So if I was to go out of that and look at test, if I do ls-a, you can see that there is no .git file. And if I try to do like Git Status, it says fatal, not a Git repository. So if you get this error, and I think a couple of you have gotten this error in the past week, it just means that you're not in a Git repository. You're not in something that can interact with Git. Cool.
So, you know, I remember when I started this, I was Git initting all over the place. And my teacher told me, stop doing that. Like, there's one place you should do it.
Yeah, you should never do it in a place that you don't want to do it. There's undoing it is basically just deleting this .git file.
Okay.
There's some code that you can run to do that if you just Google it. It's like a rm space rf something .git. Or you can just like open up your like if you're using a Mac, you can open up like the Finder, and like there's a view option where you can like show the hidden files. I forget where it is. I think it might be in preferences that you can show the hidden files, and then you can just delete the .git file and you're fine. I've run into a few issues where some students have Git initted in their base repository of their computer, so they turn their entire computer into a Git repository. You definitely don't want to do that.
So if I was doing it right, but I had a Flatiron directory with these other subdirectories, would it be in the Flatiron directory that I would do a Git init?
No, you only want to do a Git init in a folder itself, if that makes sense. So if I had like, I think your Flatiron would be similar to my like lectures. No, it would be similar to this. It would be similar to my labs. It would be similar to this, where I have all my different stuff here, and let's say each of this is a section. I wouldn't do Git init in labs. I would do Git init in here. But the thing is, when you clone something down, it automatically does the Git init for you.
Oh.
So if you're cloning something, you don't have to do Git init. The only time you have to do a Git init is if you're creating a folder. So let's say I create a new folder, call it like lab 2 or something, and I want to turn that into something that can communicate with Git. I would do Git init in lab 2. Like I would go in lab 2 and then do Git init.
Okay.
And now see it's initialized the Git repository here.
Okay. Thank you.
Yeah, no worries.
That helps a lot.
It's super confusing. I think like, yeah, Git is a lot. So yeah. Anything else? Because there's one last thing about stashing that I wanted to mention.
Yeah, I mean, I'm actually confused with the Git init part.
Yeah.
But, I think I need to read it first.
Yeah, just you almost never have to do a Git init for the course of this whole curriculum. You almost never have to do a Git init. So with the exception of that one lab that they ask you to do it, you don't have to do Git init almost at all.
Yeah.
So don't worry too much about that. Last thing I wanted to talk about was Git Stash. And Git Stash is useful because let's say that you're working on a project with another person. I unfortunately don't really have a good example to show this, so I'm going to stop this share. So let's imagine that you're working on a project with another person, and you've made some changes, but your project partner also made some changes, and your project partner pushed all of their changes up to the remote. And now you have all these new changes here that are going to conflict with your changes. That's when you do a Git Stash. And so Git Stash, kind of like what the word implies, you're stashing all your changes, and then you're going to take their changes, pull them down, and then you can reapply your stash changes after that. Git Stash is usually my go-to when I like mess something up. So yeah, that's just like a good thing to know that exists. Awesome. You got everything down.
Are we going, I mean, in this, are we going to have teams working together for?
It really depends actually. Like for projects, I will say for the full-time program, we try and get you guys in pairs and work on projects together. I know for part-time, it's harder because of like conflicting schedules, but I'm gonna like, when it comes to project time, I'll send out a poll or something to see who would like to work in pairs, and I'll like try and like coordinate your schedules when you mostly work, and then if it works out, we can maybe work in pairs, because I think there are a lot of benefits to working with.
Yes, because if I don't know certain things, right, the other one will definitely know.
For sure, for sure. Yeah. So when we get to projects, I'll definitely have that option for you, if you want to work with someone else.
So somebody new wants to learn
Yeah.
science.
Start them young. All right. Any last questions about anything I covered, about anything that's coming up? Awesome. I think it's a good idea to try to like clone down this the study group materials repo that I have, and set up the remote. And then at the start of Thursday's study group, we'll just make sure that everyone has that set up right, so that we can pull down new changes. And of course, just like Slack me if there are any issues with any of that. Cool. Awesome. Let me stop this recording. I think I can only stop.